Okay, great. It's time, so we can start. Welcome to each and everyone who had joined on time. Thank you so much for your valuable time, and I'm sure that you are going to learn one of the core tools, important tools in Lean Six Sigma with the help of practical example. You're also going to understand what is the best methodology to learn this important tool. Okay? Yes, great. Please type into the chat box at any point of time if you're having any questions. I'm happy to answer all your questions and ready to cover all the points that you are looking for. Great, thank you so much. So let me share you the screen and let's start with the first important topic, which is introduction to control chart. Let's understand what is control chart first. Can you see my screen? Great, let me make it a little bit so. Today's topic is how to learn control charts effectively and practically, right? So that we are going to learn in detail. The first topic is introduction to control chart. What is a control chart? If you see, this is the statistical technique, statistical approach that every working professional is using in their day-to-day life or professional life. And what is the intent of that? That I'm going to explain. The control chart is a statistical approach which is used to monitor the performance of your process, product, or services. It is also used to control the process by initiating actions for special causes. That means with the help of control chart, we are going to understand whether the variation that we are having into our process or product or service performance, is it only due to the normal causes or is it due to the both normal cause as well as special cause? If it is due to the special causes as well, then we are going to detect that and we are going to take the actions on them. We are going to remove them so that we can reduce the overall performance of your product, service, or processes. The third application is we can improve the existing performance of the process. So if you want to improve the existing process, we also need the control charts. Now, if I want to summarize that, if you see this magical triangle, monitor, control, and improve, for all these three important actions, we need a control chart. This control chart is also we can use for before and after comparison. That means, let's say, if you have improved the process, if you have taken some actions, and now we want to check whether performance of our process is improved or not, that is also can be checked with the help of before and after control chart. In other words, we can say we can also use the control chart for the validation. Here is a typical example that I have shown what is the control chart looks like. It is having the some average, it is having the upper control limit, lower control limit, and that is we are going to compare with respect to the specification limits. The specification limit which are specified by the customer, whereas the control limits which are calculated based on the data points or the observations that we have collected, right? So we can say analyze process in order to monitor, control, and improve it. We are going to use control charts. And again, if you want to compare before and after performance, or if you want to validate our actions, again, we are going to use this important tool, control charts. Is this clear? Great, thank you. So once we look at the control chart, what is a control chart and what is the importance of it? Now let's go into detail to understand what are the various types of control charts and how we can select the correct control chart type based on our data or based on our application, right? So I'm going into the detail of it. Please be attentive. It's a very important topic. So there are three main criteria for the selection of the control chart. The first one is we can say the type of data. We can say if you are having the continuous data, or we can also have the attribute data. So based on the type of data, we can select appropriate control chart, like control chart for the continuous data we can select, or for the attribute charts we can select. There is a third more option, which is time weighted control chart. These control charts are more sensitive compared to these two control charts, and if you want to detect the very small differences, variation into our processes, then we are going to use the time weighted control chart. Now let's come back to the point. If you are discussing about the control chart for continuous data, there are three important control charts are available. The first one is individual moving range chart. Second one is X bar R control chart, and third one is X bar S control chart. Now the selection of these three control chart, out of that, if you want to select any one, then it is based on how we are going to collect the data. That's the second metric. That means whether we are going to collect the data in subgroup or whether we are going to collect the individual data points. If we are having the data collected as an individual data point, then we need to use individual moving range control chart. Or in other case, if you have collected the data in subgroup, then the third metric is what is your subgroup size. If your subgroup size is 8 or less than 8, then we need to use the X bar R control chart, because R range is a better estimate of the variation if the sample size is less than 8. But if the sample size or subgroup size is more than 8, then standard deviation is a better estimate of the variation. And that's why instead of range, we are going to consider the standard deviation. So in that case, we need to use X bar yes control chart. So these are the selection of the control chart for the continuous data. Now let's say if you're having the attribute data, then the selection criteria is what is our area of interest. If you are going to calculate or if you are going to track the number of defectives or proportions, then we are going to use the P chart. P stands for proportions. Or in other words, if you want to use if you want to track the defects per unit, that means one unit can have the multiple defects, then in that case, we are going to use the U chart. Yes, of course, based on the whether your subgroup size is constant or your sample size is constant or not. Again, there are NP and C charts are also there, but these are the two main charts for the attribute data. Now, if you go for the weighted control chart, time weighted control charts, these are very sensitive and they are having the ability to detect the smallest variation in process as well. So the main control chart is like moving average chart, CUSUM or cumulative sum chart, and EWMA chart. So we can use the charts when we are looking for smaller differences to be detected, right? So this is again very important topic, which control chart we should select based on our intent or based on our data and the application. Is this clear to you? Great. Thank you so much. Now let's go to the third point. Now again, this is very critical point and we need to understand this. The Nielsen rules, there are 8 Nielsen rules and how we can select. The best Nielsen rules are the most appropriate Nielsen rules in our application. So the third topic is Nielsen rules and selection of correct Nielsen rules. These are also called as a test for detection of the special causes. So by using these rules, we can identify whether there is a presence of special cause, and if it is there, by which test we got that. I'm also going to explain this with the help of practical example in Excel, Minitab, as well as SIgmaXL. But before going to the example, let's understand what are these Nielsen rules and how we can select the correct types, correct test for our applications. Now, before going to the Nielsen rules, we need to understand the Deming's funnel experiment. I've explained this in very detail into my training, and we need to understand that Deming's funnel experiment is indicating that when we are going to disturb the process when it is not required, that means there is no presence of the special cause, still we are adjusting the process, then it is actually increasing the variation into the process. In other words, we can say we must change or we must adjust the process when it is needed. Otherwise, it is going to increase the variation into the process. And to study that in detail, we are going to take 4 important rules. That means we are going to adjust the data collection or the process based on these 4 important rules. And all these rules, we are going to see that when it is not needed to adjust or temper the process, and we are doing that, it is actually increasing the process variation. So what is the learning from this experiment? We need to adjust the process only if there is a presence of special cause, right? And if you are going to adjust the process without that, it is going to increase the variation. Now, how we can detect that? So for detection of that, whether there is a presence of special cause or not, there are 8 Nielsen rules. These Nielsen rules we need to understand, because if you want to understand the control chart application of it, how to detect the presence of special cause, how to initiate the actions, we must understand all these 8 Nielsen rules carefully, right? Now, based on what is the intent of them, they are categorized into these 6 categories. The first one is large shift, Large shift means we can say there is a significant something has happened into your processes. Now there are two important rules that are indicating there is a larger shift into your process. The first one is a rule number 1 and rule number 5. Now what are these rules? Let's go into the detail of it. Rule number 1 is 1 point is more than 3 standard deviation from the mean. Now this is the control chart, typical control chart, and this is drawn by having one average, upper control limit, lower control limit, and there are 3 sigma lines, plus and minus 3 sigma lines upper on the upper side and lower side of the average. This is, I've just taken the one example so we can have the clarity about what are these Nelson rules and what is the meaning of them. So the rule number 1 is 1 point is more than 3 standard deviation from the mean on either side. If you are having any 1 point which is going beyond plus 3 sigma or minus 3 sigma, we can say there is a larger shift, and this is indicated by the rule number 1, indicates there is a presence of special cause. Now the rule number 5 is again indicating the larger shift. Now what is the meaning of this? 2 or 3 out of 3 points in a row are more than 2 standard deviations from the mean in the same direction. So it is clearly indicating that our process has started shifting towards one of the control limits. So this is again indicating the larger shift, and we must take the actions as soon as we detect this rule as a presence of special cause. Right? So this is the larger shift. Now let's go to the next category, which is smaller shift. Now smaller shift is also can be detected by two rules, rule number 2 and rule number 6. What are these rules? Let's go into the detail. Rule number 2 indicates 9 or more points in a row are on the same side of the mean. So this is again indicating that our process has started shifting towards one of the control limits. The rule number 6 is 4 or 5 out of 5 points in a row are more than 1 standard deviation from the mean in the same direction. Again, it is indicating that process has started shifting towards one of the control limits. So we should take actions in this case depending on what is the criticality of your product or process or service performances. Now the third category is trend. This is indicated by the rule number 3. This is typically we can see during the tool wear or the extrusion processes where there is a trend we are going to see. Rule number 3 states 6 or more points in a row are continuously increasing or decreasing. That is indicating the trend. Again, this is the presence of special cause, and we must take the actions when we are going to see this. Now, in this case, we can limit because it's in some processes, it is a nature of the process. So we can have the higher limit by which as soon as we reach there, we should we should change the tool, or we should change the screen pack or anything that is related to the extrusion process or any other process that is showing this kind of behavior. Now the fourth category is over control. Now this is the indicated by the rule number 4, and mainly it is happening when operator or the engineer wants to control the process towards the target. That means it is always going to adjust the process at the center, and because of that we can see this kind of trend. Rule number 4 states that 14 or more points in a row alternate in direction increasing and then decreasing, it indicates tempering to the process, or it is also called as a over control. Now the fifth category is the stratification. As the name indicates, we can say this is indicated by the rule number 7, and as the name indicates, it is a combination of multiple sources that can be detected when we are having the 15 points in a row are all within 1 standard deviation of the mean on either side of the mean. Now we can say yes, this process looks very good, but also we need to identify why this is so good, right? So again, this is a presence of special cause. This is called as a stratification. And the last rule is a mixture that is indicated by the rule number 8. This indicates that we are having the data, or we are having the data points from the multiple machines or multiple operators or multiple resources, multiple suppliers, and because of that we are going to see this kind of trend. 8 points in a row exist with none within 1 standard deviation of the mean, and the points are in both directions from the mean. So no points we can say that is coming between plus and minus 1 sigma. plus or minus 1 standard deviation. So this is indicating that it is a mixture of multiple data points or multiple resources. So these are the 8 rules that we need to use for the detection of the special causes. Now we should not use all the 8 tests, because as we are going to select the more number of tests, they are going to increase the probability of giving the false signal. Now let me explain you what is a false signal. False signal is a signal when control chart indicates there is a presence of special cause when there is not. And we had seen, as into the Deming funnel experiment, if there is a no presence of special cause, still, if you are going to adjust the process, it is actually increasing the variation into your process. So it is not desirable, right? So we should not select all the tests for the special causes for monitoring as well as to control our process. We must select special set of the test depending on whether you are going to set the control limits first time or you have already set the control limits and now we want to monitor your process. In both of these cases, we need to select the different test. Okay, I have explained that in very detail into my training. So I will explain that afterwards, after some time. Okay, so this is the third important topic. Nelson rules. What are the 8 Nelson rules and how we can select the best Nelson rules based on our application and our data. Do you have any questions till the point? Great. I cannot see any questions. Okay, but at any point of time, if you're having any questions or anything in your mind that needs to be answered, please put into the comment box. Now, the fourth one is control charts in Excel. So there is an Excel template that we have prepared, and you can go through that template and we can use that for the learning of these control charts in Excel. So let me share you that. Yes. So this is the control chart template, and this includes the 5 important control charts that we are using in day-to-day basis, like individual moving range chart. So you just need to enter the data here, and the moving range and control limits getting automatically calculated, and you will get the individual as well as range chart automatically here, MR chart. Now, how these are calculated? So to understand that, I have also provided what are the calculation formulas for individual chart, what are the calculation formulas for this moving range chart, and what are the constants that I have also put here, so that we can have the complete understanding of the each control chart in detail into this control chart template. Same is for the X bar R control chart. We can see here what is the data, what is the subgroup size, how we can calculate the average chart, range chart, and what are the formulas that we are going to use here, and what are the constant tables depending on the subgroup size. So everything is mentioned here, so you can also learn this in detail. Same is for the X bar yes control chart, P chart, and U chart. So this is if you want to use the Excel template or Excel to monitor entire your data, we can also use this template so that we can have the better control over our process. We can start the implementation of the control chart in order to monitor, control, and improve our processes. Right? So this is the again important part of the using the control charts by Excel. Right? So this is the next important topic. Now it's time to learn these control charts with the help of example. Due to time constraint, I'm not going to explain all the control charts to you, but I'm going to explain one control chart, how we can use that or how we can perform that by using the Excel, SIgmaXL, and Minitab in all of these 3 statistical softwares that I'm going to explain to you. Okay, so let me share you that example and let's go into the detail. Let me explain you what is a procedure that we can use. So let me share you the screen for example. So this is an example. I'm going to take the X bar R control chart because this is more, I can say the frequently used control chart that many industries are using. Okay, so this is the example. Please learn it carefully. A company wants to monitor runout of the walls. Data is collected at every 30 minutes with subgroup size of 3. So here we can see we are having the data, it's a continuous data. We are going to collect the data for runout, which is continuous, and subgroup size is 3, which is less than 8. So we are going to use the X bar R control chart in this case. The first one is data is continuous, data is collected in subgroup, and subgroup size is less than 3. So this is indicating that we need to use the X bar R control chart. This wall has an upper tolerance of 0.08 mm or 80 microns. Data is in microns is available in the worksheet that I'm going to share with you. Data is collected for 25 numbers of subgroups. Now let's see how we can perform that into the Minitab first, and then I will also explain how we can use the Excel template as well as the SIgmaXL statistical software to perform this X bar R control chart. So let me share you the Minitab screen first. Yes, so this is the data. So we are having the 3 subgroup size. So the first wall is having the 3 runouts, x1, x2, x3, right? So we have the 3 subgroup size, 3 readings. Then we are having the second wall, again 3 readings, third wall, again 3 readings, right? So this is the data collected for all 25 walls. Now we want to use the control chart because we can see here the data is continuous and we are having the subgroup size which is less than 3. So how to do that? Go to the stat, we can select the option for control charts, and then we need to use the variable charts for subgroups. After that, we need to select the X bar R control chart. We can also see why we need to select that. Monitor the mean and standard deviation or variation. Sorry, monitor the mean and variation, which is a range because subgroup size is less than 3 of your process when you have a continuous data in subgroup. Works best with subgroup sizes of 8 or lesser. Right? So select this option. Now we can see there is a drop down which is open. Here we can see if you are having all observations for a chart are in one column, then simply we need to select that column and what is the subgroup size. But in our example, we have subgroups in row of columns, right? So we can select this observation for a subgroup are in one row of columns. So select this option. We need to select all these columns like x1 to x2, x1, x2, x3, or we can also select this like this, x1 to x3. So this is indicating the subgroup size, right? After that, we can select the X bar R options. Here, if you want to fix the control limits, we can also mention what is the mean and standard deviation. If you have already conducted that and you have calculated that, this is used for the monitoring. But let's say if you are going to calculate that first time. So here we can see if you go to the test, then there we can select all the 8 types of Nielsen test, or we can select the specific test because we want to reduce the number of false signals. Here we can select perform the selected test and we can select which test we want to select. For this example, as we want to learn how we can perform, let's select this perform all tests for special causes. Here we can see all the 8 Nielsen rules we have selected, then click OK. After that, click OK. So we will be getting the X bar R control chart here. Now again, there is a common mistake that people are doing during the interpretation of this. People are directly going for this X bar chart, right? So that should not be. We must understand the range chart first. We must see whether the range is in control. If everything is in control, then and then only we need to go for the X bar chart. So that is a basic mistake again people are doing. So please check. Now, if you look at the range chart, we can see, yes, all the points are in control. So we can look at the X bar chart. And here we can see the point number 22, which is indicating that there is a presence of special cause indicated by the point number 1 or the one above it. That indicates that there is a violation of the first rule. You can see here as a sample 22 test failed as a 1. It is actually for the both rules 1 and 5 that we can also see into the session window here. 1 point more than 3 standard deviations from the center line and 2 out of 3 points more than 2 standard deviations from the center line. So both of these indicating that there is a larger shift into your process. So we need to take the actions on this so that we can control our process. We can remove the presence of special cause. Right? So this is the methodology that we can use in Minitab to draw this X bar R control chart. Now let's see how we can use the Excel template. Yes, so this is the template that I have explained to you. And in this template, I have already formulated everything like formulas and the graph based on this calculation and constant. So you just need to enter the data here. Once you enter all this data here, like x1, x2, x3, and after that, everything is getting automatically calculated. So we'll also get what is the X bar control chart and what is the range control chart. By looking at the range, we can see all the points are in control. So we can look for the X bar control chart. And again, that is indicating the point number 22, which is the presence of special cause. Now, as this is a template where it is not indicating you there is a presence of special cause and we should take the action. So we need to understand that. That's the thing in case of this control chart template. Now let's go to the third part, that is how we can use this SIgmaXL statistical software so that we can draw the control charts here. This is again the one of the powerful statistical software and simplest because it is the Excel add-in software. So in that we can select anywhere into this data, go to this control chart, and we can see there is an option for X bar R. Click on that. There is an option for use entire data table. So click on that, click next. Here again, there are two options. Stacked column format, there is a one numeric data column and we are having some subgroup size, or we are having the subgroups across the rows. So similar to the Minitab, again, we need to select this option, subgroup across rows, second one. And numeric data variable, we need to select all these three rows, three columns, numeric data variables. As we are going to calculate the limit, so keep the default selection as it is. Or in case if you are going to use this for the monitoring purpose, we can use the historical limits. We can click on test for special causes, sigma zone lines, so we can also understand 1 sigma, 2 sigma, 3 sigma. In case of our control chart, we can also add the title and then click OK. Once we click on OK, so again, it is indicating, it is giving an output for X bar R chart, very beautiful results with the violation of the test. Yes, here it is. So we can see here, let's look at the range chart first. Yes, we can see everything is in control. So we can go for the X bar chart. And again, it is indicating the point number 22, which is failing the test number 1. If you go to the detail, we can also get out of these 8 Nielsen rules. What are these 8 Nielsen rules? And out of these 8, for which data point, what are the tests for which we are failing, right? Like observation number 22, that is failing the test number 1 and test number 5, right? So this is a beautiful output. Again, we are getting similar to the Minitab. So we can also use this statistical software to use the control charts. Again, there are very beautiful option that is present like SIgmaXL chart tools. If you want to edit, if you want to exclude subgroups, that is similar to the Minitab that we can also perform into this SIgmaXL statistical software. Yes. So we had seen this fifth point, that how we can perform this control chart into the Excel, SIgmaXL and Minitab. Now the next topic is how we can learn the control chart with mentoring support. So I have formulated this entire training in a systematic way, starting from various concepts that are used into the control charts. Even if you don't know anything about the control charts, and if you want to learn that in detail, yes, you can learn into this training program because that is started from scratch, assuming that you don't know anything about the control charts. So if you learn that, simply visit here vijaysabe.co/control and you can learn this control chart most effectively and practically. Okay, so there is one comment or question. What is the subgroup size? Okay, that's a great question, Akash. Subgroup size is like that. Many times we are not collecting data as an individual unit. That means we are collecting the 2 or 3 data points or 5 data points more frequently. And we are taking the average of that point and we are using that average to plot the control chart. So that is called as a data collected in subgroup. For example, let's say if in the example that I have explained, every 30 minutes, we are going to collect the 3 data points, right? So these three data points will be plotted on the control chart as a single data point or single dot. Okay. Now, how we are doing that? We are taking the average of all these three data points and we are using to plot the control chart. So here we can see the data is collected in subgroup and having the subgroup size of 3 in our example that I have explained. Is this clear, Akash? Great. Thank you. Now, the last topic for the today's live streaming is question and answer on control chart. So if you're having any questions, please put that into the comment section and I'm ready to answer all your questions. Yes. So if you have individual data, how will you plot on control chart? In that case, we need to use the individual moving range chart, IMR control chart that I have explained, right? So it's a depend on the what is the type of data and how we are going to collect the data. If your data is continuous and if you have not collected data in subgroup, then we should use the IMR chart. Or if you have collected the data in subgroup, then depending on the subgroup size, we should select the X bar R or X bar ES control chart. What equation will be put in the Excel file for subgroup size? Subgroup size is not an equation. That's the data collection method that we are using, right? Now, if you want to, okay, if you want to consider the subgroup size into formulas, then let me share you the screen again. Here it is. So we can see based on the subgroup size, the constant we are going to select here, right? Whether it's X bar R control chart and X bar ES charts. Let's go into the formula. If you see for average chart, the center line is X bar, that's average, X double bar. Upper control limit is X double bar plus A2 into R bar. Now what is A2 here? For that purpose, we need to go here, A2. Now this A2 we need to calculate based on the subgroup size. Here we are having the subgroup size as 3. So we can select A2 as 1.023. We need to add that value here. And R bar is nothing but the range. So we can get what is upper control limit for the average chart and lower control limit for the average chart. Similarly, if you want to calculate for the range chart, then we need to go for the D4 and D3 constant. So how we can calculate that? We can see here, we are having the subgroup size as 3 and we should select the factors for control limits. Like we can select the D3 or D4. D3 is 0, we can select here, and D4 is 2.574, right? So we can get the lower control limit as 0 because it is multiplied by 0 into R bar. So we can see into the range chart, we are having the 0 as a lower control limit and upper control limit will be D4 into R bar. Is this clear, Akash? Okay, the question is for individual, how will you select the A2? Okay, let me share you again. If you go to that template, we can see for individual, we are having the different formulas, right? And different table. Here we are having the E2 and E2 is a constant here. So that we need to select here. So here we need to select as a for the subgroup size 2 because for the range chart, we are going to calculate this range for the 2 individual readings. For example, if you go to the range chart, here we can see the first data point is missing because we are having the one data point collected at a time. So we cannot calculate what is the range there, right? But if you can see, we can calculate the range for the first and second data point. So we can see the range chart is going to be start from the point number 2 because this range for the point number 2 is calculated the difference between the observation number 1 and observation number 2, right? So the range chart is starting from the point number 2, considering the subgroup size as 2. So we have going to consider the E2, D2, and D4, the constants for the subgroup size 2 for the range chart, moving range chart, right? Is this clear? Here is not a range chart, it's we can see the moving range, right? So we are going to calculate the difference between two consecutive data points, and that is going to consider it as a range here. Great questions, Akash. Do these formulas assume not going to assume here as the data is normal, but the stability is a more important concept, that we must have the stable process. That means whatever the variation that we are going to see into our processes, that should not be huge due to the special causes. That should be normal causes, because if your stable process is not stable, then control limits is going to be frequently changing. So we need to take the actions on your processes. Let's say if you are going to use the control chart first time, then you will be seeing some of the out of control points. So we need to investigate that. We need to take the actions on them and try to remove them, or you can go for the fresh data collection and again see what is the changes that we can see into the process. We can use the before and after control chart in that case. That's a great question, Steve. Thank you so much for asking this. Great. Any other questions? Just waiting for your questions. Okay. If no questions, then I'm really thankful to you for attending this entire live training and webinar patiently and asking so much of questions which are very meaningful. And I'm sure that from this free training, you have got the significant idea about what is a control chart and what are the various dimensions of it. If you want to learn again the control chart in detail, simply visit this link and you can get the entire curriculum that you are going to enroll or you are going to learn along with my mentoring support. Thank you so much for your valuable time, and let's learn another important topic into the next video.